Right, well, while it's changing, good morning to you all. And I'm here from Autodesk, and what I'd like to talk to you about this morning is really on the software side of this equation and try and explain to you how geospatial technology integrates into the future of describing things. So I have that thing up here now. I just need to get my laptop's misbehaving. Can you just help me with this for a second? Oh, okay, here we go. All right, great. Okay, I'm all set. So as you've been hearing all morning, around the world we have growing needs in terms of infrastructure, right? You heard Ewood talk about 6 billion people going to 9 billion. It leads to all sorts of needs in terms of energy, in terms of urban dwelling, moving people, handling traffic, enormous challenges around the world. There is no question that not only do we live in interesting times, but we live in very challenging times. And almost all of these infrastructure needs around the world are getting more and more urgent by the day. And this leads to a couple of challenges. The first one is that our ability to address these growing infrastructure needs is behind our need for these infrastructure. McKinsey estimates that the world needs about $60 trillion worth of infrastructure over the next, by the year 2030, and can really only fund about $24 trillion worth of work. So we have a large gap, and so no matter how much technology we throw at this problem, just addressing the ability, the capacity to fund these projects, to staff these projects is an enormous challenge. But clearly, technology has to be a part of the solution. We were talking this morning about making things more efficient, generating more and being able to do more with the same amount of capital, if you will. And technology has to absolutely play a role in closing this infrastructure gap. But is technology part of the problem itself? Because right now, I think if you look at these two axes on which infrastructure projects have to work, one is the fact that these projects are massive. More and more projects, because of the backlog, if you will, in the developed world. So if you look at the United States, we regularly get a D-. I think this year we did slightly better and we got a D+ in terms of how we are doing in terms of our infrastructure needs. And that's really a backlog of roads, bridges, airports that need to be refurbished, right? So, and these projects are complex. They're massive. They require significant upgrades and need to be done in very, very tricky conditions. And in the developing world, you're working against numbers. I grew up in a city which has 22 million inhabitants. There is no city in the world that can plan for 22 million inhabitants, right? It's an enormously complex challenge, and these projects require a lot of coordination. So on the one side, projects are massive. On the other side now, because of everything that you're seeing in the world of social networks and connectivity and just the world we live in today, people are more informed than ever before and more engaged. You can be sure that if something goes wrong in one of those projects, in 1960 you would probably find out about it 30 days later. Today you'd find out about it about 30 seconds later, right? I mean, any of you who drive in Europe or in the United States, you have this application called Waze, W-A-Z-E, that is owned by Google. How soon do you find out that there's a traffic jam? You find out almost instantly that there is a issue somewhere, and that's all coming because everybody's connected and everybody's informing everyone else as to what's going on. So you have this challenge, and what I would posit to you is that technology today, therefore, needs transparency. People need to know what's going on. You can no longer hide behind, well, this is complex information. We can't tell you what's going on that bridge redesign that we're doing. And in order to enable transparency, people who are working on projects need to understand impacts at any time. If some condition changed, if some new information becomes available, you need to understand the impact of that change in real time. You need to make decisions in context, because in these massive projects, in their environmental conditions, regulatory conditions, hundreds of stakeholders, lots of constraints that you're working with. So when you're going to act on some kind of information coming in, you have to make those decisions in context. And to make decisions in context, you really have to address this challenge we've had in our industry, in the infrastructure industry, in the geospatial industry for many years, which is people do not share information. I can't tell you how many times I have been at an engineering and construction company or a utility, a water utility, a gas utility, and the GIS department does not talk to the engineering department. You go to, an engineering project, the city information is not accessible to the citizens. This is no way for us to continue going forward if we are to make technology more efficient, if we are to do things in real time and do more with less. The amount of information available, though, if you forget the silos for a second, is tremendous, right? You have all of this rich geospatial information available. You have 3D models coming out, as Jay was talking about this morning. You're sensing the world in real time. You've got LiDAR, photogrammetry, you've got sensors, you've got all of these platforms that are giving you information about your infrastructure. This is what the geeks like to call big data in their, in general cloud computing terms. But it really is a big blob of information, and all of that information really relates to infrastructure in the context of these projects. So from a technology perspective, we have to develop something that is suited for the modern world of working with big information, if you will. Unfortunately, technology today is largely 2D. If you look at any GIS system out there, it's 2D. And it's really strange. In our private lives, we are ready to use Google Earth, but in our business lives, we go back to looking at maps or cartographic representations of information. Furthermore, these are limited by CPU. You cannot actually load up models of arbitrary sizes. You can't look at a dam project or a rail project or a road project in its entire scale. You have to break it up into smaller chunks, because till today, software is not designed to handle 10 kilometers or 100 kilometers worth of information. And certainly, most software today promotes silos. GIS, CAD, engineering, here's point cloud data. It's all set up for specialization as opposed to bringing it all together for decision making. And this is where we believe switching the context to building information modeling, big information, building information, is the core of how we go about changing this, and specifically applying BIM for infrastructure. One of the misunderstandings of BIM, there's actually 3 misunderstandings. I'm sorry, let me just get a sip of water. 3 pieces of misunderstanding. First of all, everybody thinks BIM is about 3D. 3D is part of what BIM is, but the key about BIM is the I in BIM, which is information is the source of the value that gets created around BIM. Models that are created are certainly fully descriptive in terms of being 3D models, but just as important, every element in those models has information associated with it, so you can do analysis, you can make decisions, you can understand quantities, you can understand distances, you can understand all the relevant pieces of information. Another misunderstanding about BIM is the word building is thought about as buildings, as nouns, things, places where people live or work. We really mean the act of making something, the act of You can see I'm getting very emotional about things. I'm choking up. So it's the act of building, it's the act of making something that is the building and building information modeling. And in BIM for infrastructure, geospatial information underpins the information that is present inside BIM. So knowing where things are helps you make decisions in context. So BIM for infrastructure is the modern way to address this challenge of both transparency towards stakeholders as well as making decisions in real time. So let me show you some examples. This is the port of Long Beach in California. I was talking about, handling the scale of information. Now, this video is going to play for a little while, and you're going to look at it and think of it as either a movie animation or something I recorded for you using Google Earth. This is actually a model created out of terrain data, GIS data, building data. When you combine all of those sources of information in a product we call InfraWorks. So it is a BIM for infrastructure product. This model is not just a nice flyby. Every building has information on it. This is 3,200 acres worth of information. There's 66 cranes, 23 piers, and there's one more piece of data that I got to tell you. 80 shipping berths that were shown in that at full accuracy. So that is a model upon which you can make real decisions. Now, we didn't stop there. Just to show you that scale can be handled by modern technology today, this is actually the entire county of Los Angeles that we are going through now. So think about, you have cities in which you're making decisions. And many times when you're doing urban planning, you have to do it at the scale of one city block. Today's technology, BIM for infrastructure, lets you work at urban scale. You can put 10 kilometers, 100 square kilometers, 1,000 square kilometers of information, fully accurate, dimensionally accurate, terrain accurate, all the GIS data, ERP data, all surfaced through this interface. And here now, for the city of Los Angeles, they're able to now put a bridge, the 6th Street Bridge, which is a real project they're working on, in the context of the entire city model. So BIM is now, it's a city scale modeling experience. So now you can do decisions in context. I showed you one example of a bridge that was LA. This is Norway. And this is a real project that they're undergoing, which is trying to select both the approach and the type of bridge that they have to put in place at this one location. So you can see all of the terrain imagery. This is 3D imagery generated from a terrain model. And now they can study the various options that they have in the bridge design. What kind of bridge would look best in that environment, which is a big decision that they need to make. How does it look from the various viewpoints of the city, and make that decision in context, as well as select which one of the roads would that bridge best connect to. These are huge decisions. These bridges are millions, if not billions of dollars sometimes, and many times you have these projects where later on you run into an unintended consequence. Well, you can make the decision in context using BIM for infrastructure. I talked about making real-time impact assessments. So if you're designing, for example, a stop sign or a certain turn signal within the context of a city, again, because you have all of the information within which you're going to design that intersection, you don't have a theoretical, well, I'll create the digital model, I'll have a road, then the people will go out on the field, and they'll tell me if things are obstructing. You have the actual digital representation of that street corner, and the environment will tell you, based on rules and procedures and codes, whether those stop signs are obstructing anything, or if there's landscape information, or what is in the way of making those turns. So modern technology, BIM for infrastructure, can help you make these impact assessments. And because this technology is enabled by cloud and mobile, the information that is being generated can be readily shared with citizens. This is actually the city of San Francisco. They're doing a an entire redesign of the Market Street, which is a major thoroughfare. And rather than trying to describe to their citizens what the changes would look like using pictures or watercolors, they created a 3D model that their citizens can view using an iPad or the device on the bottom left, which is, one of those classic owl things that you see on top of skyscrapers, to visualize what the world would look like. You can imagine wearing one of those Oculus VR goggles and looking at the world based upon where you're located, right? So the 3D information, BIM for infrastructure, is a very effective communication vehicle for your citizens. And then finally, BIM for infrastructure is accurate enough to drive the shaping of the earth that Ehud was talking about. So if you actually want to cut the terrain based on the digital model, or you want to scan the world and bring it into the environment, scan to BIM for infrastructure, the scale and the ability of BIM for infrastructure to handle all of this information and pump it out makes that possible. So in summary, I think one way to look at geospatial coming together in the world of infrastructure with all of this data is to really look at big information being the pivot around which a new experience, which is immersive, accurate, and fully realizable, can be built. And that solution stack is BIM for infrastructure. It's what Autodesk is busy building with partners such as our friends here on the panel, so we can bring all the information and help you visualize your world before you build it. Thank you, and I look forward to your questions.